the next conversation will be about the next internet. What is the next stage of the internet? We will talk about Web 3.0 and the context of trusted connectivity. We will have a wonderful expert speaker. He's the CEO at GuardTime. His name is Mike Gault. We will have a small company introductory video, and then afterwards we will look forward to his presentation. Thank you very much.
GuardTime was founded with a mission to make the world's information universally reliable, without reliance on the risk of human trust. GuardTime's invention, KSI, was initially designed to support the Estonian government in its quest for zero-trust systems, meaning that systems can provide a formally verifiable mathematical proof of correctness of operations. GuardTime's business model is to build partnerships with companies in every industry, build the product and go to market. It is said that if Google organizes the world's information and makes it universally available, then GuardTime validates that information and makes it universally reliable. Let's hear their ideas about the next internet, Web 3 and trusted connectivity.
Hello, everyone. If I were to poll the audience and ask you which of these statements is correct, I suspect the majority of people would choose the option on the left. But that would be a mistake, because in the history of invention, the first iterations of any invention were always mocked. And we are very bad at predicting the future. Over the next 10 minutes, I hope to convince you that blockchain will be the next internet. It will be the solution to trusted connectivity. And not only that, it's being built right here, right now, in Estonia. So the inventors of the internet were thinking about exchange of data, even in a decentralized network, even under the threat of nuclear attack. They weren't thinking about data at rest. They weren't thinking about identity. And they certainly weren't thinking about the exchange of digital rights. Let me explain. The inventors of the internet were thinking about securing the channel. And we end up with these islands of trust, where we focus on the connectivity between the channels and not the data itself. The opportunity for the next internet is to think about the data as well as the channel. And we have this concept, we have in the military, we have physical supply chains and left of launch attacks. But we don't have the concept of information supply chains. They don't exist. And we have these trusted authorities that secure the channel. But within these organizations, the security comes from trusted insiders and process. Identity. The inventors of the internet were not thinking about identity. And today we lack a universal digital identity system that can allow users to present the credentials they want, to the people they want, at any time they want, without third parties controlling access. And we don't have the concept of digital rights. The inventors of the internet were not thinking about the trillion-dollar industries that would be produced and abuse digital rights. Bitcoin is obviously not a very good medium of exchange. It's not a good currency, and that's okay. Bitcoin did one thing. It proved a concept. It proved that you can transfer digital rights across the internet without a trusted authority. And everything we do on the internet today involves the exchange or transfer of digital rights, whether it's email, social media, or reading the news. These all involve an exchange or transfer of digital rights. And this has led to the abuse of those rights by companies. In Europe, we try to legislate, and we have GDPR. But the opportunity for the next internet is to make those rights explicit and to integrate those rights into the application layer protocols of the internet. So blockchain as the next internet has much promise, but in order to make it a reality, we need orders of magnitude more throughput and performance than what we have today. And so enter Estonia. Over the last 3 years, Estonian professors and researchers at Tallinn Technical University, at University of Tartu, and the Institute of Cybernetics have been developing the foundations of a new internet. And the challenge they were set was, can you build a blockchain that would allow every interaction, every transaction, and every event, every piece of data on the internet to be verifiable without trusting central authorities? And so they started to work. And their first observation was that we're all doing blockchains wrong. There are maybe 20,000 cryptocurrencies. All of them are based on either UTXOs, in Bitcoin's case, or accounts. And the problem with this is you have coordination, you have dependencies, you have more than one transaction unit involved. But that's not the case with bills. Think about physical cash. When I walk into a coffee shop and buy a coffee with a 10-euro bill, there's no coordination needed. The only thing that happens is a change of ownership. And so this is the principle that they have been building on. Instead, in blockchains, they have this concept called a state tree, which manages the state of the blockchain. Instead of using accounts and balances, we can use tokens and owners. And this means we can partition the state, and there is no coordination needed between the different partitions. And this allows true linear scale. The Estonian Central Bank, together with the ECB, as part of their research into the digital euro, tested this approach, and they were able to deliver 2 million transactions a second. But that's not the point. The point is, linear scale means you can keep going. And if we've learned one thing from cryptocurrencies, is that you cannot retrofit scalability into the design. And so the alternative is we keep going on with PKI. PKI has been an amazing invention and extremely successful in its original use case, which is sharing secrets across an insecure channel. But the complexity and cost of key management means that it's universally not used as a mechanism to verify data. And so the way I want you to think about blockchain, it is a decentralized, censorship-resistant machine for creating tokens. Bitcoin showed that you can have proof of uniqueness, but the opportunity here is to make PKI practically universal so that we can integrate the technology into the application layer protocols of the internet and have verifiable data, verifiable credentials, and the explicit exchange of digital rights on every interaction on the internet. Sadly, in the public sector, blockchain has been hijacked by consulting companies who try and sell something on the left. But this is absurd. The idea that public sector hospitals, the idea that insurance companies are running consensus protocols, or running nodes, or running governance committees is totally the wrong approach. Ultimately, blockchain will be invisible. The way the next billion users come online will be that it's integrated into the application layer protocols, and people are just using it without even knowing it. And so the title of this conference exposes our thinking. We're thinking about trusted connectivity. We're thinking about securing the channel between all these different parties, when instead we should be thinking about verifiable data. If you have verifiable data, why do you need trusted connectivity? You need connectivity, of course, it needs to be available. But this change in mindset allows you to have information supply chains. And to have a warfighter here be able to verify the provenance, the supply chain of information, all the way back to a satellite where that data was created. And everything we do in society is the same principle. Everything is a process. You have data producers and you have data consumers. And the ability to verify the properties of data through its life cycle is the opportunity for a new internet. And this is the model today. Today, it's been the same model for the last 30 years. Because we do not have verifiable data, we rely on search and hope. We download events and we search for anomalies in the network with Splunk, with Darktrace, with ArcSight. But no, we want to say that if you have verifiable data, you can make the data the perimeter itself. And instead of searching for anomalies, you can have real-time situational awareness about the state of the network. Estonia understands this, by the way. It was the first government to actually use blockchain in production. And they were thinking about data integrity. And very few people have the same opinion about what data integrity even is. But we want to make the point that every breach starts off with an integrity breach. The number one cause of security breaches today is misconfigurations. But if you have verifiable data, if a network is simply a set of digital assets, and you can guarantee the information supply chain for every asset, you have a different way of thinking about security. And so a good example here is Israel, the European Space Agency. By tokenizing data, by creating tokens for data that do not rely on centralized authorities, we have a mechanism to create an information supply chain so that everybody on that chain can verify the provenance. They can verify the properties of the data without a centralized authority. And so we're all familiar with what the pitch for Web3 is, what we think it is, and what is being built right here in Estonia are these three things. Verifiable data, where data can be verified without centralized authorities. Verifiable credentials, where I can use the credentials I want and present those to whoever I want, whenever I want. And the explicit exchange of digital rights, so that every interaction on the internet, I can choose to use Facebook and share my data, but we can make that choice explicit in the application layer protocols of the internet. And lastly, we're doing this in the open. We have a community here in Estonia. Dirk is going to join me now from the Tallinn Technical University. We're building this together. If you're in the public sector, we'd love to hear from you. If you use data, we'd love to hear from you. If you're a university student that is looking for the next big thing in the internet, in data, please come and talk to us. Thank you. Thank you, Dirk. Any questions?
Yes. Thank you. Thank you. Very interesting and great to hear that the next internet is being built in Estonia. As a member of academia, how could one contribute and what kind of contribution you're looking for, and what would be the benefit for contributing as a member of academia?
Dirk, do you want to answer that one? Please introduce yourself.
Yeah. Hello, glad to be here. My name is Dirk Draheim. I'm full professor of information systems technology from TalTech, Tallinn University of Technology. So I get your questions right about the research opportunities in this domain currently and how to be involved. Yeah, so what we recently understood is ultra scalability. So how to scale with blockchain, how to achieve performance, which was always a major obstacle to the utilization of blockchain in the past years. So, you know, with the KSI cache technology that has been developed by GuardTime with mathematical knowledge of Taltech. It's a long cooperation and so on and so on. What we have achieved there in the prototype is 300,000 transactions per second. 300,000 transactions per second. Bitcoin is 7 transactions per second, which is maybe like the 50 supermarkets, the load of 50 supermarkets. So what is needed when you actually want to utilize blockchain technology in the large scale worldwide, nationwide, worldwide, you need this performance. You need to be ultra scalability. You need to have ultra scalability. And we have understood mathematically how to do that, and it has been shown now in the clean room understanding of a digital currency. What has to be researched next, of course, how to launch such ultra scalability in the Web3. And we are close to understand that, so here we need further research. So we research the full Web3 stack, of course, not only technology-wise, because we are a large university with all kinds of expertise, so all along the institutional economic stack, from cultures, from regulations, down to the technologies, all this needs to be investigated. So to fully have a Web3 in the future, people talk about that. You can read about that in Harvard Business Review. There was now the statement, it's the internet, it's the next internet, it's the internet of the future, what are the obstacles and so on. But to really do it, what our opinion is, it must be about a web of everything, it must be about a web of everyone, yes, so but what does it actually mean? So we need a amalgamation, a convergence of intranet and internet. How would that be done? These are research questions that need to be researched, and yeah, so all technology-wise, when you're from academia, you do technology research, I assume. Software-defined networks, SDN, sensors, IoT, consensus mechanisms, how to integrate with blockchain to get this amalgamation, convergence of internet and internet. Because we can claim a lot, but we need to make concrete steps and put it into, to utilize it and put it into technologies. That's what GuardTime doing in the last 2 decades always. That's why we have this important strategic partnership. So if you want to be involved, just contact us from Taltech, or just contact GuardTime. It's both is the correct way to contact us, right?
Thank you very much for your time. Thank you.